Hello there, and welcome to Nightfall Science. Tonight, we explore a haunting possibility that first contact may have already happened, hidden inside an unexplained signal, an ancient artifact, or a forgotten observation that humanity failed to recognize. Settle in, let your breathing slow, and imagine the evidence waiting quietly in our past. Let's begin. First contact may not arrive with an announcement. It may not begin with a voice, a clear picture, or a message repeated across every telescope on Earth. It may begin as one uncertain mark inside an old record, a brief radio tone, a flash of light, an unusual object moving through the solar system, a pattern recorded once and never seen again. Someone notices it, studies it, searches for a familiar explanation. Then the observation is placed inside an archive. Years pass, the equipment changes, the people who collected the data move on. The unexplained pattern remains. If another civilization attempted contact in this way, humanity might already possess part of the evidence. We may simply not know what we received. There is no confirmed evidence that first contact has occurred. No radio signal, optical pulse, artifact, or interstellar object has been verified as extraterrestrial technology. Every serious candidate examined so far has either received a natural or human explanation, or remained too incomplete to establish what produced it. But this does not mean humanity would recognize contact immediately. Discovery and understanding are separate events. A telescope can receive a signal before anyone knows what it means. A camera can photograph an object before its importance is understood. A detector can preserve a pattern that future scientists interpret differently. The physical event happens first. Recognition may happen much later. Imagine a radio telescope operating during an ordinary night. Its antenna moves slowly across the sky. The receiver measures millions of narrow frequency channels. Computers preserve the strongest events. Most are familiar: satellites, aircraft, radar, signals reflected through Earth's atmosphere, internal electronics, natural radio sources. Then one signal appears. It is narrow, strong, and strangely organized. The telescope receives it for less than 2 minutes. Then the source moves outside the instrument's observing beam. The signal disappears. The telescope cannot immediately turn back. Its design follows the sky at a fixed rate. By the time another observation is possible, the transmission has ended. The data remain. A researcher writes a note beside the unusual pattern. Follow-up observations begin. The telescope returns to the same region. Nothing appears. Another observatory listens. Silence. Months pass. Years. The signal never repeats. A satellite can create interference at the exact moment an extraterrestrial pulse appears beneath it. The message reaches Earth physically. The receiving opportunity fails. SETI searches have covered only a small fraction of the enormous space of possible directions, frequencies, signal durations, repetition rates, and transmission methods. Search databases exist partly so future researchers can understand where, when, and how earlier observations were conducted. This search space is sometimes imagined as a cosmic ocean. Humanity has sampled parts of it, but not every depth, not every current, not every location. Listening for one kind of radio signal around one nearby star does not test every possible technology. An extraterrestrial civilization might transmit using frequencies blocked by Earth's atmosphere. It might use pulses too fast for an older instrument to record. Its signal may spread across a wide band and resemble natural noise. It may encode information through polarization, through precise timing, through several frequencies observed together. A receiver designed for narrow tones might ignore it. The message could be present while the search software classifies it as background. Technology shapes what becomes visible. Before radio astronomy, an artificial radio signal could pass through Earth without leaving any recognized trace. Before high-speed digital storage, very brief pulses might be lost between measurements. Before modern computation, complex patterns could remain hidden inside large datasets. Before networks connected observatories quickly, another telescope might not learn about a candidate until the transmission had stopped. Every generation listens through the assumptions built into its instruments. A signal that does not match those assumptions may remain unseen. Imagine an extraterrestrial message encoded as a slow pattern. One radio pulse arrives tonight. Another appears 6 months later. A third arrives 3 years after that. No single observation looks meaningful. Each event is stored by a different telescope. One is classified as interference. One is marked as an unexplained transient. One remains inside raw data that no researcher examines directly. Only after decades does someone compare the timestamps. The gaps form prime numbers, or a geometric sequence, or the orbital period of the source planet. The message was never contained inside one event. It existed across time. A genuine discovery must survive ordinary explanations. Yet caution creates another possibility. A real signal could resemble interference so closely that researchers reject it correctly according to the evidence available at the time. The signal is placed aside. The distant transmitter does not repeat. Humanity never gains the additional observation required to reconsider. First contact may be missed, not because scientists were careless, because the universe provided only one incomplete event. A convincing example of this difficulty appeared in the search around Proxima Centauri. During observations made with Australia's Parkes radio telescope, researchers found a narrowband candidate later known as BLC-1. It appeared to come from the direction of the nearest star system and initially survived several filtering steps. Detailed analysis eventually showed that it was most consistent with human-made radio interference rather than an extraterrestrial transmitter. BLC-1 demonstrates how an exciting candidate can become ordinary through patient investigation. The direction was intriguing. The frequency structure was intriguing. The association with Proxima Centauri was intriguing. But intrigue was not enough. Researchers searched for related signals. They examined how the frequency changed. They compared observations taken while the telescope pointed away. The pattern connected with terrestrial electronics. The candidate became a lesson in interference. This is what good verification looks like. The explanation became less extraordinary as more evidence appeared. A true technosignature would need to move in the opposite direction. Every new test would make a human or natural explanation more difficult. The signal would remain connected with one astronomical location. Independent observatories would detect it. Its structure would contain information. Predictions based upon the signal would succeed. Perhaps it would describe a planet that telescopes later confirm. Perhaps it would repeat a terrestrial transmission that had reached the source years earlier. Perhaps several types of evidence would agree. One candidate alone would not carry the conclusion. A network of evidence would. But what if an older candidate was observed before those tests were possible? The equipment may no longer exist. The exact electronics may be undocumented. The local radio environment may be impossible to reconstruct. The raw data may have been lost. Only a printed chart remains. Humanity cannot return to the original moment. A partial first contact may be more likely than a perfect one. Transmitters and receivers do not coordinate before they know one another exists. A sender does not know when Earth is observing. Earth does not know when the sender transmits. Their instruments, rotations, weather, and schedules must align. A message can begin while the source star is below the horizon for most observatories. One telescope detects the end. Another begins recording too late. The first evidence becomes a collection of incomplete views. A civilization may try to prevent this through repetition. But repetition is not guaranteed. The signal might be produced by an event that occurs only once. A spacecraft passing near a powerful gravitational lens. A transmitter operating during a brief alignment. A farewell archive sent before a system changes. A radar observation aimed toward an object that happens to lie beyond Earth. The sender may not even know the beam crosses us. First contact could therefore be accidental on both sides. They did not call Earth. We did not intend to listen. Our paths intersected. Another form of missed contact may not involve a radio signal at all. It may involve matter. In October 2017, astronomers discovered 1I 2017 U1, known as Oumuamua, the first object confirmed to have entered the solar system from interstellar space. It moved on an open trajectory that showed it was not gravitationally bound to the Sun. Oumuamua was discovered after it had already passed relatively close to the Sun and was moving away. Humanity did not watch it enter the solar system. We noticed it during departure. The object was faint. It moved quickly. Astronomers had only a limited period to study it before it became too distant for detailed observation. Its shape, rotation, and small non-gravitational acceleration produced scientific discussion. NASA sources describe it as a natural interstellar object, with several proposed natural processes explored to explain its properties. No evidence confirmed it as artificial technology. Yet Oumuamua revealed something important about detection. Objects from other star systems can pass through our neighborhood before we notice them. The first confirmed interstellar visitor was not identified years before arrival. A radio pulse arrived in Another optical event appeared decades later from the direction the object had traveled. Future researchers reconstruct the path and timing. The object may have transmitted while leaving. The three observations connect. This fictional example shows why archives from different sciences may need to be searched together. First contact may not arrive inside one discipline. It could be distributed across astronomy, planetary science, radio engineering, and historical records. The message may be hidden, not only in noise, it may be hidden between categories. One team studies objects, another studies signals. Neither compares their results. A future analysis sees the relationship. Humanity may have already created enormous archives capable of preserving such clues. Modern sky surveys repeatedly image large regions. Radio telescopes store broad-frequency data. Spacecraft monitor particles and magnetic fields. Planetary defense systems track moving objects. Meteor networks record the atmosphere. No person can inspect every observation. Software selects what appears interesting. The definition of interesting becomes powerful. An algorithm trained to find asteroids may reject a moving object with an unusual appearance. A program searching for radio interference may remove an extraterrestrial pulse because its shape resembles a satellite. A transient search may ignore slow signals. A slow search may ignore brief ones. The filter protects researchers from overwhelming data. It can also hide what it was not designed to recognize. Artificial intelligence may help revisit these choices. It can compare patterns across large archives, identify events that do not fit known categories, search for repeated structures at different frequencies. But artificial intelligence also learns from examples. If every training example of a signal comes from human technology, it may classify alien technology as the closest human category. The problem is not simply finding anomalies. It is understanding which anomalies matter. Scientists would need methods that remain open to unexpected structures while still rejecting the vast amount of ordinary noise. A true first contact discovery may begin with someone questioning a discarded event, not because it looks dramatic, because one small feature remains inconsistent. The frequency drift does not match a satellite. The timing follows a distant planet. The polarization changes in a way consistent with interstellar travel. The event appears in two observatories that never exchanged equipment. If the source lies 100 light-years away, the civilization existed at least 1 century ago. Earth sees its old light. A reply will reach it 1 century from now. By then, more than 200 years separate the sender we detected from the civilization receiving our answer. First contact happened, but no shared present ever existed. This is the nature of communication between stars. Even when a message is recognized immediately, it belongs to the past. A missed message deepens the delay. A signal waits 30 years in an archive. Then humanity spends 10 years verifying it. A reply begins 40 years after reception. The sender has already moved 40 years farther into its own history. Contact is not one synchronized meeting. It is a chain of delayed discoveries. Perhaps the sender expected this. Its message may include repetition across centuries. The signal recorded long ago is only one part. A new transmission is still approaching. The old archive provides the schedule. Researchers calculate the next arrival. For the first time, humanity knows where and when to listen. Telescopes across Earth and space prepare. The source star rises. Receivers cover a broad range of frequencies. The predicted moment approaches. At first, only noise. Then the pattern returns. The old candidate and the new signal align perfectly. The mystery ends. The missed first contact becomes confirmed second contact. Humanity realizes that someone has been calling for generations. Not continuously, patiently. The earliest signal was not a failure. It was the beginning of a sequence we had not yet learned to see. Or perhaps nothing returns. The old event remains alone. Humanity may never know. This uncertainty is part of the topic's quiet power. First contact could have occurred without leaving enough evidence to become knowledge. A signal can touch the planet and disappear. An object can pass through the solar system before being discovered. A pattern can remain inside an archive without being recognized. The universe does not guarantee that important events arrive clearly. It gives observations. Meaning must be built from them. For now, Every historical candidate remains unconfirmed. The WOW signal remains famous because it was unusual and never repeated. BLC-1 became a lesson in human interference. Oumuamua became the first confirmed interstellar visitor, not a confirmed artifact. Other unexplained observations continue to inspire investigation, but none establishes that extraterrestrial intelligence has contacted Earth. The honest conclusion is not that contact happened. It is that recognition has limits. Humanity listens through incomplete instruments, limited time, crowded frequencies, changing technology, and assumptions shaped by our own experience. A real message may be obvious, or it may resemble something ordinary. It may repeat for years, or appear once. It may come from a distant star, or from an object already within the solar system. It may contain a complete library, or only one unexplained pulse. Tonight, imagine an old observatory after its final night of operation. The telescope rests beneath the sky. Its computers have been removed. Paper records sit inside boxes. Most contain routine measurements, numbers, charts, notes written in fading ink. One page holds an unusual mark, a signal from a star, a brief event that no one could explain. The researcher who studied it followed every reasonable path. No repeat appeared. The page was archived. Decades passed. Outside, Earth continued orbiting the Sun. The signal continued beyond the planet. The source star continued shining. Perhaps the event was only interference. Perhaps a natural phenomenon. Or perhaps, for 72 quiet seconds, the distance between two technological worlds became very small. Not physically, informationally. One civilization sent, another almost understood. The evidence now waits for context that may never arrive. The history of astronomy is filled with moments when the universe appeared to behave like technology. A pulse repeats with machine-like precision. A burst arrives from deep space. A star dims as though something enormous has moved in front of it. A radio telescope detects a pattern that seems to come from a nearby planetary system. For a brief moment, the familiar boundaries become uncertain. Perhaps this is nature. Perhaps it is interference. Perhaps someone has spoken. Then more observations arrive. A natural explanation begins to form. The extraordinary candidate becomes a neutron star, a cloud of dust, a magnetar, or a microwave oven near a radio telescope. These moments are sometimes called false alarms. But that description can be misleading. They are not failures. They are lessons. Every false alarm teaches scientists how the universe behaves, how instruments can mislead us, and what a genuine alien signal would need to do differently. They also reveal something important about first contact. The first real signal may look almost identical to the false ones, at least in the beginning. One of the most famous examples began in 1967. The instrument had been built to study distant radio sources. Its recordings were not clean digital images. They appeared as lines drawn across long rolls of paper. Bell examined enormous amounts of this material by eye. Most of the patterns were familiar. Natural radio sources, interference, instrument behavior. Then she noticed something unusual. A small section of the chart contained what she later described as a kind of scruff. It did not resemble the ordinary signals surrounding it. The pattern appeared again from the same place in the sky. When the equipment was adjusted to observe it more clearly, the source produced pulses separated by approximately 1 1/3 seconds. The timing was remarkably regular. A signal repeated over and over with a precision that seemed difficult to imagine from a natural object. The source was temporarily given a playful nickname connected with the idea of little green men. The astronomers did not announce the discovery of aliens. They investigated. They searched for changes caused by Earth's motion. Every new observation becomes another piece of the same explanation. Peritons were not the end of mysterious radio bursts. In 2007, astronomers reported a powerful event found inside archival observations made at Parkes. The signal had lasted only a few milliseconds, yet it appeared to come from far beyond the Milky Way. This event became known as the Lorimer burst. It was the beginning of the study of fast radio bursts. For a time, researchers did not know whether the signal represented a new astronomical phenomenon or another form of terrestrial interference. The earlier peritons made caution essential. Both types of events could appear brief. Both could display frequency-dependent delay. Both had first been detected at the same observatory. The comparison was unavoidable. If microwave ovens could imitate deep space dispersion, perhaps the new burst was another local effect. More events were needed. Then other telescopes began detecting similar bursts. Some repeated. Their positions were connected with distant galaxies. Their signals traveled through immense amounts of intergalactic material. Fast radio bursts became recognized as real astrophysical phenomena. Their exact origins remained under study. Then an important event occurred within our own galaxy. In 2020, telescopes detected a powerful radio burst associated with a magnetar. A magnetar is a neutron star possessing an extraordinarily intense magnetic field. The event demonstrated that at least some fast radio bursts can be produced by these extreme natural objects. NASA observations connected a Milky Way fast radio burst with the magnetar SGR 1935 plus TW154, establishing that magnetars can create at least some of the powerful millisecond radio events observed from distant galaxies. Again, a signal that might once have appeared technological revealed a natural source. The burst was extraordinarily energetic, brief, distant, and unusual. Yet nature was capable of producing it. This expands the challenge. An alien transmitter does not operate inside an empty spectrum. It operates among neutron stars, magnetars, stellar flares, lightning, plasma, black holes, and many phenomena humanity has not yet discovered. The message could be like a sentence heard through a closing door. Only the first sound reaches us. Another famous mystery began not with radio, but with starlight. NASA's Kepler Space Telescope watched the brightness of many stars. The mission searched for planets by observing tiny, regular decreases in light. When a planet passes in front of its star, it blocks a small fraction of the light. The dip repeats each orbit. From the timing and depth, astronomers can estimate the planet's size and year. Most transits are orderly. Then one star produced something unusual. Its catalog designation was KIC 8462852. It became widely known as Boyajian's star, or Tabby's star. Instead of small, periodic dips associated with an ordinary planet, the star displayed irregular decreases in brightness. Some were remarkably deep. The dimming did not repeat with one simple planetary schedule. Something appeared to be blocking different amounts of light at different times. Many natural possibilities were considered. Clouds of dust, fragments from comets, material connected with planetary collisions, changes associated with the star itself. The unusual pattern also inspired a technological possibility. Could enormous artificial structures be orbiting the star? A sufficiently advanced civilization might build large collectors to gather stellar energy. A swarm of such objects could block changing portions of the star's light. This idea was never the default conclusion. It was one possibility among many. Still, it captured public attention. A star appeared to behave in a way that could be imagined as engineering. Follow-up observations across different wavelengths became important. Large solid objects should block colors more evenly. Fine dust affects shorter and longer wavelengths differently. The dimming proved stronger at shorter wavelengths. This favored small particles rather than opaque megastructures. NASA-supported observations found that the unusual long-term dimming of Tabby's star changed with wavelength, in a way consistent with uneven clouds of dust, making large solid alien structures an unnecessary explanation. The star remained scientifically interesting. Its behavior was still worth studying. But the evidence moved toward a natural cause. The alien explanation did not fail, because imagining technology was forbidden. It lost strength because another model explained more of the data. A signal appearing from its direction naturally attracted attention. BLC-1 had several qualities expected from a candidate technological signal. It was narrow in frequency. It displayed a drift. It appeared during observations directed toward Proxima. Researchers did not announce contact. They investigated the data. They searched for related signals. They compared observations of the target with observations away from it. The deeper analysis revealed similar patterns at other frequencies. These signals were connected in a way suggesting one human-made source or family of sources. BLC-1 was ultimately attributed to terrestrial radio interference. The BLC-1 investigation concluded that the Proxima Centauri candidate was most consistent with interference from human technology, while also providing a detailed test of the methods used to evaluate possible technosignatures. This candidate demonstrates how close an event can come to satisfying early expectations. Correct direction, narrow bandwidth, apparent frequency drift, limited appearance during target observations. Each feature increased interest, but interest is not confirmation. A genuine extraterrestrial signal would need to survive the search for related interference. BLC-1 did not. The hidden human source did not need to resemble one obvious transmitter. Electronic equipment can produce many harmonically related frequencies. A signal at one frequency may be part of a larger pattern. Once the wider family is found, the candidate changes character. What appeared isolated becomes connected with terrestrial technology. This is why researchers study not only the candidate, but the surrounding data. A real message might also have related components. Several channels, a beacon, and a data stream. Reference tones. The difference would be in how those components behave. They would remain linked to the astronomical source. They would appear at distant observatories. Their drift would match the motion of the source system. They would not occur whenever a local device entered one operational state. The investigation must ask where the pattern lives. In the sky, in the telescope, in the software, or in the environment around the observatory. Sometimes the answer moves between those layers. A natural astronomical source enters the telescope. The instrument modifies it. Software processes it. The final pattern includes features from all three. Researchers must separate them. A signal from another civilization would also be transformed by every step. Interstellar plasma. They may have missed us. Two civilizations can exist inside one another's data without becoming known. Contact depends upon persistence. A message repeated long enough. A search continued long enough. Archives preserved long enough. And minds willing to revisit uncertainty. The famous near-contact events on Earth form a kind of training sequence. Pulsars teach that natural precision can resemble engineering. Peritons teach that ordinary human devices can imitate deep space phenomena. Fast radio bursts teach that a mysterious class can require years and many telescopes to understand. Tabby's star teaches that indirect signs of technology must be compared across wavelengths. BLC-1 teaches that the most exciting direction in the sky does not remove the need to examine every terrestrial explanation. Oumuamua teaches that visitors from other star systems can enter and leave before humanity gathers all the measurements it would like. Each case closes one easy path towards certainty. A real detection must survive them all. It must remain artificial after pulsars are considered, after microwave ovens, after magnetars, after dust, after satellites, after unusual comets and asteroids. The better humanity understands false alarms, the narrower the space for error becomes. This improves the chances of recognizing a true message. A future candidate may first resemble BLC-1. Researchers apply the same tests, but this time, no related terrestrial frequencies appear. The signal is detected from several continents. Its drift matches the orbit of a known exoplanet. Then it resembles a pulsar, regular pulses, but the intervals begin changing according to prime numbers. It resembles a fast radio burst, brief and powerful, but it repeats with an encoded image. It resembles the dimming of Tabby's star, yet the brightness changes according to a mathematical schedule. Every earlier mystery becomes one test. The new signal passes each one. Humanity's history of almost contact prepares it for actual contact. But what about evidence already collected? Could one of these lessons contain something overlooked? The confirmed explanations should not be ignored. Pulsars are neutron stars. Peritons came from local microwave ovens. BLC-1 was human interference. The wavelength behavior of Tabby's star supports dust rather than solid megastructures. These cases should not be reopened simply because alien contact is exciting. Evidence matters. The future contains more observations than the past. The question is not only whether humanity missed first contact, it is whether we learned enough from every almost contact to recognize the next one. Pulsars once appeared almost impossible. Now their signals help astronomers measure space and time. Fast radio bursts once appeared as one mysterious event. Now hundreds have been studied. Interstellar objects were once theoretical visitors. Now humanity knows that natural material from other planetary systems can pass through our own. Every mystery expands the vocabulary used to study the next. A real technosignature would become part of this same process. It would appear strange. Researchers would compare it with everything known. Most comparisons would fail. The signal would continue. Its structure would deepen. At last, technology would become the simplest explanation remaining. Not because people wanted it to be true, because the evidence left nowhere else to go. Until then, the almost contacts remain useful. They keep the search honest. They prevent excitement from becoming certainty too soon. They remind humanity that nature is creative, that our machines are noisy, that one observation is fragile, and that something truly new may first appear almost indistinguishable from a mistake. Tonight, imagine the moment Jocelyn Bell first notices the strange pattern inside the paper chart. It is only a small, irregular mark. Nothing about it reveals a neutron star. No image shows a dense sphere rotating in space. There is only the recording, a trace of energy, a pattern waiting for a mind to ask why. The correct explanation creates an entirely new class of astronomical object. Now imagine another chart, another era. A future researcher notices one line. It repeats. The first explanations are tested. Pulsar, satellite, radar, magnetar, instrument, dust. None fits. Another telescope sees it. Then another. The pattern grows. Numbers emerge. The universe has offered something new again. This time, the explanation is not a new kind of star. It is a new kind of history. A technological civilization beyond Earth. Perhaps that event lies ahead. Perhaps its earliest fragment lies behind us. First contact may have happened as a signal too brief to confirm. An object discovered too late. A pattern divided between archives. An archive is a kind of telescope pointed backward. It does not look into the past by receiving ancient light. It looks backward by preserving what earlier instruments already saw. A signal may pass Earth only once. A strange object may appear during one night. A flash may last less than a second. The universe moves on, but if the observation is recorded carefully, the moment remains available. Not in the sky, inside the archive. This makes old astronomical data more than a historical record. It is stored opportunity. A future researcher may understand something that the original observer could not. The instrument may have been limited. The explanation may have been incomplete. The observation itself can still contain the clue. First contact may already exist in this form, not as a known message, as evidence waiting for the right comparison. There is no confirmed alien signal hidden inside old astronomical records. No photographic plate, radio tape, military sensor report, or lunar observation has been verified as extraterrestrial technology. But many archives were created before technosignature searches became systematic. They contain views of the sky gathered for other purposes: stars, planets, asteroids, radio sources, atmospheric events, spacecraft, and countless anomalies that were never followed deeply because they did not match the original project. A telescope designed to measure star positions may record a brief flash. A camera built to track meteors may capture an object moving too slowly for a meteor and too quickly for an ordinary satellite. A radar system monitoring near-Earth space may detect a reflection that never returns. A lunar instrument may record a radio burst from a direction hidden from Earth-based observatories. Each event can have many natural or human explanations. Most probably do, but first contact, if it occurred unexpectedly, may have entered data collected for something else. The observer does not always know what kind of discovery is being made. Imagine an astronomer working 100 years ago. The night sky is recorded on glass. A telescope gathers light for many minutes. The image forms slowly across a photographic plate coated with light-sensitive material. The pieces were collected by different sciences, different nations, different generations. The sender produced one event. Humanity divided it into categories: astronomy, radio engineering, atmospheric science, planetary defense. The message became scattered. Recovering it would require searching across boundaries that did not exist for the signal itself. Light does not care which institution records it. A pulse does not know that one telescope belongs to a university and another to a military system. An interstellar object does not know which nation owns the radar tracking it. The universe produces one event. Human archives separate it according to human purposes. This separation can protect knowledge through redundancy. It can also hide relationships. Consider radar. Radar systems transmit radio waves and measure reflections. They track aircraft, weather, satellites, asteroids, space debris. The return signal reveals distance and motion. A reflective object in space may appear as a brief echo. Most echoes are understood, known satellites, fragments of rockets, natural meteors, the moon, planets. But a system can record something that does not fit immediately. A reflection appears at an unexpected distance. Its velocity is unusual. The signal returns once, then disappears. Perhaps the object tumbles. Perhaps the radar geometry changes. Perhaps the equipment creates a false target. Or perhaps something crossed the beam. Military radar archives may contain many observations unavailable to ordinary astronomy. Their instruments often monitor wide regions continuously. They can detect objects that scientific telescopes were not watching. They may preserve precise timing, direction, velocity. Sometimes only summaries remain public. Sometimes the original data are classified, lost, or stored in formats no longer used. This creates a difficult boundary. Important observations may exist without being available for scientific comparison. A future contact investigation might need cooperation between civilian and military institutions. A candidate appears in an astronomical archive. Researchers discover that a defense radar recorded an object at the same time. One dataset provides the optical flash. Another provides motion. Together they reveal a path. Without access, the relationship remains hidden. This does not mean secret archives contain alien spacecraft. There is no confirmed evidence of that. It means observational coverage has always been broader than public astronomy alone. A low-resolution image may show only a bright pixel. A future high-resolution mission could return to the location. Most likely it finds an ordinary boulder, but the archive provides coordinates. Without the old image, no one would know where to look. This is how historical data guide future observation. An anomaly is not a conclusion, it is a target. Perhaps first contact has already happened as an unrecognized target. A point on the moon, a faint object in a stable orbit, a radio burst linked to one location, an unexplained light near a planet. The original evidence remains weak, but future instruments can test it. The past asks the future to look again. Another archive exists in meteor observations. Every day, small objects enter Earth's atmosphere. Most are natural fragments from comets or asteroids. They heat, glow, break apart. Networks of cameras and radars record their paths. From those paths, scientists estimate their speed and original orbit. Occasionally, an object may appear to approach from beyond the solar system. Measurement errors can create false interstellar trajectories. Atmospheric forces complicate reconstruction. Still, a true interstellar meteoroid could enter Earth's atmosphere. Natural material from another planetary system may already have reached the ground. If an artificial fragment entered, it might look like an ordinary meteor. Heat could destroy much of it. Small pieces may fall into ocean, desert, ice, forest. The event becomes one bright streak. A camera records it. No one searches the ground. First contact through matter may occur without any object being recovered. The message burns before it can be read. A civilization sending probes would probably design them to avoid such an ending. But not every artificial object is a messenger. Debris from another technological system could drift between stars. A damaged component, a spent sail, a fragment from a collision. It may enter our atmosphere accidentally. The object contains no greeting. Its material alone reveals engineering, an unusual alloy, layered structure, isotopic composition inconsistent with natural processes, microscopic patterns. Yet if the fragment is not recovered, the evidence remains only a trajectory. The archive preserves motion, not material. A later event may produce another fragment. Researchers compare the paths. A common origin appears. Until that connection is justified, Each field uses its own natural models. This is correct. Natural explanations should be explored fully. Technology enters only when it explains more with fewer unsupported assumptions. A genuine contact discovery may therefore begin slowly. One paper examines unusual radio emission. Another studies a planet's atmosphere. Another reports repeating optical flashes. Years later, someone notices that the timing agrees. The source planet rotates every 17 hours. The radio pulses repeat on the same period. The optical flashes occur when one longitude faces Earth. The atmosphere contains an industrial molecule. Now the pieces support one another. The civilization may have been visible for decades. First contact happened gradually. No single day contains the beginning. The concept of first contact becomes difficult to define. Was it the first photon received, the first anomalous record, the first time two archives were connected, the first scientific confirmation, the first decoded message? Perhaps contact has several beginnings. Physical contact begins when information reaches Earth. Scientific contact begins when its origin is understood. Cultural contact begins when humanity responds. Historical contact may begin much earlier, hidden inside data. The title of this journey asks whether first contact already happened and was missed. The answer may depend upon which beginning we mean. A signal may have touched Earth without being recognized. That is physically possible. A confirmed extraterrestrial exchange has not occurred. That is the current evidence. Between those statements lies the space of archives, possibility preserved in incomplete records. No conclusion, but many reasons to look carefully. Photographic plates are one path, radio tapes another, radar logs, lunar data, meteor cameras, spacecraft instruments, old sky surveys. Even recordings from communication systems may matter. A powerful distant pulse could enter a terrestrial antenna, not designed for astronomy. It appears as static. A communication engineer logs the interruption. Another station experiences it, seconds later. The event is blamed on equipment. The records remain separate. Future analysis reconstructs a wave moving across Earth from one astronomical direction. The first receiver of an alien signal may not be a telescope. It may be a navigation system, a deep space network antenna, a weather satellite, a laboratory detector. Compared with cosmic timescales, our memory is small. An alien beacon repeating every 1,000 years would have appeared at most once during recorded astronomy. We would not know it repeats. A beacon repeating every 10,000 years could cross Earth many times during human evolution and never twice during technological history. Its reliability from the sender's perspective becomes invisibility from ours. This may help explain silence without requiring emptiness. Signals exist, but their timing falls outside our memory. The archive is not long enough. Future humanity may change this. 1,000 years of continuous observation. 10,000. An observatory or network maintained across civilizations. Patterns currently invisible become clear. A flash recorded in the 21st century returns in the 31st. The original data remain readable. The two events align. People living then discover that their ancestors captured the first pulse. First contact becomes a project across 1 millennium. This future possibility gives present archives meaning. We may not understand every event. We can preserve it for those who might. Preservation is an act of scientific humility. It says, our interpretation may be incomplete. Someone later may know more. The sender of an alien message relies upon this humility without knowing it. Its signal may be too strange for us now. The best thing we can do is save the evidence, not call it alien, not discard it completely. Preserve, document, allow comparison. This balanced approach avoids both extremes. Believing every anomaly, ignoring every anomaly. The archive holds uncertainty without forcing resolution. One day, another observation may decide, or no deciding evidence ever arrives. The record remains an honest question. Imagine a future researcher opening a digital collection from our century. The interface displays millions of candidate events. Most have explanations: satellites, radar, natural transients, instrument noise. One event is marked unresolved. The raw data are complete. Local interference logs survive. Several observatories were operating. The researcher compares their archives. A second weak detection appears. It was never flagged because it fell below the original threshold. A third exists in lunar data. The arrival times align. The wavefront crossed the Earth-Moon system from one distant star. The signal contains a broad pattern that older software treated as noise, perhaps one small point that does not belong. No one noticed it then, or someone noticed and wrote a question mark. The plate waited. Dust settled. Generations passed. Above the building, the sky continued changing. The source of the point moved through the galaxy. If it was a signal, it continued beyond Earth long ago. Yet one trace remains. The past has not answered. It has preserved the question. Nearby, another archive holds radio tape. A faint tone crosses one channel. A lunar instrument recorded a pulse at the same moment. A radar log shows an object. The pieces remain separated, perhaps forever. Perhaps only until someone asks the right question. What happened across all these instruments on the same night? The answer may be ordinary. A satellite, a meteor, a solar event, a timing error. Science would gain clarity, or the answer may remain strange. The observations point outward, toward one star, one repeating schedule, one artificial structure. Then history changes. Not because the signal arrived today, because humanity finally understood what had already happened. First contact may have been 72 seconds long. One frame, one radar echo, one line on a magnetic tape, one pulse on the far side of the moon. The event itself may have been small. Its meaning would be enormous. For now, no archive contains confirmed proof. The honest search continues. Preserve, compare, test. Return to the unexplained without forcing it to become extraordinary. Allow ordinary explanations every opportunity, and remain open to the possibility that one record may resist them. Perhaps first contact is still ahead. Perhaps it happened too early. Perhaps it is waiting inside an archive. Or perhaps the real signal will arrive tonight and become an archive before anyone understands. A message does not need to travel as light. It can travel inside matter. A machine may cross the distance between stars slowly, quietly, carrying information through the darkness for thousands, or even millions of years. By the time it reaches another planetary system, the civilization that launched it may have changed completely. Its builders may no longer exist, yet the machine could continue following its instructions. Observe, wait, preserve, and respond when the destination becomes capable of understanding. If such a probe entered the solar system long ago, first contact may already have happened physically. An object from another technological civilization may have crossed the boundary of the sun's domain, passed the outer planets, observed Earth, and settled somewhere nearby. Not close enough to be obvious, only close enough to wait. There is no confirmed evidence that an extraterrestrial probe or artifact exists within the solar system. Every known spacecraft, asteroid, comet, and interstellar visitor studied so far has remained consistent with human technology or natural processes. But the solar system is enormous. Humanity has examined only a small fraction of its objects closely. A machine the size of a vehicle could remain difficult to distinguish among countless rocks. A smaller probe could be almost impossible to see unless it transmitted, reflected light unusually, produced heat, or altered its motion. The idea of an automated interstellar messenger has appeared in scientific discussions for decades. A probe could travel to another star system, observe its planets, wait for signs of intelligence, then begin communication locally. This would solve one of the greatest difficulties of interstellar messaging. A radio signal cannot change after it is sent. It carries assumptions made at departure. A probe can adapt. It can study the receiving civilization, learn which frequencies it uses, observe how it represents numbers, listen to its languages, then construct a message suited to the world it actually finds. The machine becomes more than a recorded greeting. It becomes an interpreter. Imagine a probe launched toward the solar system before modern humans existed. Its builders identify Earth as a planet with oceans and atmospheric chemistry associated with life. They cannot know whether intelligence will develop. They send the probe anyway. The probe may have been part of a larger survey. Thousands of machines sent toward promising planetary systems. Most never arrive. Some fail. Some encounter worlds containing only microorganisms. One reaches Earth. Its presence does not mean the builders knew humans would appear. We are one unexpected result within a broad experiment. The artifact's mission log may list other destinations, nearby stars, planets showing atmospheric oxygen, ocean worlds, young systems. The map becomes a guide. Other probes may exist elsewhere. One may be located near another star. Another may still be traveling. The builder civilization could have created a network of observers across the galaxy, not a communication network intended for us. A scientific survey. Humanity discovers one node. This changes the search. Astronomers look for similar orbital behavior around other worlds, a known pattern, a material signature, a radio identification sequence. The artifact teaches us what to search for. First contact may have happened in one silent object. Then the object reveals a galaxy filled with old instruments. A probe could also hide closer, on the moon. The lunar surface changes slowly compared with Earth. There is no rain, no ocean, no vegetation, no active weather to bury or erode objects quickly. Micrometeoroids and radiation still alter the surface. Dust moves, impacts occur, but an artifact could remain recognizable for extremely long periods. A civilization wishing to place a durable marker near Earth might choose the moon. It is easy to observe, gravitationally connected with our planet, visible to any civilization developing astronomy, reachable once spaceflight begins. A marker on the lunar near side could eventually be photographed. A marker on the far side would remain hidden from direct Earth observation. It might be intended for a civilization capable of orbiting the moon. The placement becomes another threshold. First learn astronomy, then develop spaceflight, then discover the object. Human missions have examined only limited regions directly. Orbital cameras have mapped much of the surface at impressive resolution. Still, small objects remain difficult to identify among rocks, shadows, and cratered terrain. An artifact several meters wide could appear as an unusual boulder, unless its geometry is obvious, unless it reflects light strongly, unless it transmits. The location can be reconstructed only by reversing millions of years of stellar motion. Humanity may spend centuries solving it. Another possibility is that the object was created locally, not by an extraterrestrial civilization arriving physically, by a self-replicating probe. One machine enters the solar system, uses asteroid material, builds smaller observers. The original probe fails. Its descendants remain. Each carries part of the program. No single object contains the complete archive. Humanity finds one small machine near an asteroid, then another near the moon. Their components fit together conceptually. One measures atmosphere, one monitors radio, one maps planets. The system functioned as a distributed observatory. First contact happened many times physically. Machines entered our environment. We simply mistook them for natural objects or never detected them. A distributed network would be difficult to remove accidentally. If one unit failed, others continued. Some may still operate. The discovery of one allows prediction of others. The probe's orbit reveals a pattern. Similar gravitational regions are searched. Faint objects appear. The solar system contains an ancient scientific infrastructure built by someone else. This idea may sound immense, but the machines could be small, a few meters, centimeters, microscopic sensors. Technology does not need to announce itself through size. The difficulty of finding it grows as scale shrinks. A microscopic probe could attach itself to a spacecraft, enter Earth's atmosphere, remain inside dust. Without active transmission, recognition would be nearly impossible. But a tiny machine must still obtain energy, protect information, and perform useful observation. Extreme miniaturization creates its own limits. Larger artifacts are easier to maintain and easier to find. A long-lived probe may choose a balance, small enough to travel efficiently, large enough to repair itself. A few meters, perhaps tens of meters, comparable to human spacecraft. The object could hide not because it is invisible, but because space is vast. Imagine placing one automobile somewhere within the asteroid belt and asking astronomers to find it without knowing its location. Even if the vehicle reflected sunlight, it would be extraordinarily faint. The challenge becomes greater if the object rests beyond Neptune. The outer solar system contains darkness, cold, and enormous volume. The scenario demonstrates how artifacts may reveal intelligence through function rather than language. A device performs something nature does not: focuses, measures, transmits, corrects its position. Intention appears through repeated action. A silent artifact may also exist beneath a planetary surface: Mars, the Moon, an asteroid. Burial protects against radiation and impacts. A probe may land, deploy instruments, then cover itself with local material. Only antennas or sensors remain exposed. After thousands of years, dust hides those too. Orbital images reveal nothing. A rover passing nearby may detect unusual metal beneath the ground. The reading is interpreted as a meteorite. No excavation follows. First contact is missed by meters. This possibility highlights the limits of planetary exploration. Human missions have examined tiny portions of other worlds directly. Rovers travel remarkable distances, but planets are vast. An artifact could lie near a landing site and remain unnoticed. A future mission may find one by accident. A drill enters a layer. The material is too regular. The structure continues deeper. The machine was present before the surrounding sediment formed. Its age is astonishing. No signal had announced it. The artifact waited beneath dust. First contact happens through geology. The probe may contain a record of Mars from a time when its environment was different, or Earth from afar. It may have been sent to study several worlds. A lander on Mars could monitor the solar system quietly. Earth's radio emissions eventually reach it. The machine identifies a technological species on the neighboring planet. Perhaps it transmits toward us. But Martian terrain blocks the signal during most rotations. One human orbiter records a pulse and dismisses it. The lander later loses power. Its final message remains incomplete. A future mission discovers the machine long after its attempt. First contact already happened. The receiver failed. The physical evidence arrives later. An alien artifact may also be found inside material returned from an asteroid or comet. A sample return mission collects dust. Most grains are natural minerals. One microscopic fragment contains layered structures, perfectly repeated channels. An alloy arranged at scales difficult to explain through crystallization. At first, contamination is suspected. The collection tools are examined. The spacecraft materials are compared. Different interpretations compete. The artifact becomes an extraterrestrial equivalent of an ancient ruin. Except the builders did not share our biology or culture. The machine may be more difficult to interpret than any archaeological site on Earth. Yet physical function provides clues. Energy flows, signals, materials, where. The probe's operation can be reconstructed. A storage region contains patterns. A navigation system references stars. A damaged antenna points toward one direction. Step by step, the civilization behind the object becomes visible. The builders valued redundancy. Every critical component has several copies. They planned for deep time. Their mathematics uses several states rather than binary. Their sensors extend into wavelengths humans rarely study. Their idea of a machine may include living tissue. The artifact is partly biological. Cells repair structures. Mineral layers protect them. Technology and organism are intertwined. The probe may have survived because it grows. A dormant seed inside space. When near a star, it gathers energy, repairs damage, produces new instruments, then becomes quiet again. Humanity's categories of machine and life begin to blur. The probe may be a living messenger, not conscious, still biological. Its builders engineered an organism capable of interstellar travel. The artifact contains hereditary instructions and memory. Contact occurs with a designed life form. This would transform biology, yet caution remains. A strange self-repairing system could still be natural if found on a living world, inside deep space. With maps and structured information, technology becomes more likely. The combination matters. One sign never carries the entire conclusion. A probe may also have been destroyed. Only fragments remain. A strange alloy within lunar soil. A geometric shard embedded in an asteroid. A radioisotope pattern indicating artificial energy use. Researchers find pieces before finding the whole. The fragments are catalogued separately. One came from a moon mission, another from an asteroid sample, a third from a meteorite. Their composition matches. They originated from one machine that broke apart long ago. First contact becomes reconstruction. The artifact may have entered the solar system, struck an object, and scattered. No intact message remains. But the pieces prove design. A small etched pattern survives on one surface. Several fragments fit together digitally. The combined diagram shows a star map. The second created recognition. The third created communication. Each generation adds one stage. This is the rhythm of the entire topic. Contact may already have happened physically, but history records only what was understood. The machine's arrival does not automatically create awareness. Its signal does not automatically create meaning. Discovery may wait. Perhaps the probe is still outside the solar system, approaching slowly. Its first radio message already passed Earth and was missed. The artifact will arrive later. When it does, its archive may mention the earlier signal. Humanity will learn that first contact happened before the messenger arrived. The two forms of communication reinforce one another across time. A beam first, matter later. The sender designed multiple chances. This could be happening now without any visible clue. An object between stars is extraordinarily difficult to detect. Cold, small, dark. It reflects almost no sunlight until it enters the outer solar system. Even then, telescopes may not notice. The probe's journey remains hidden until the final stage. There is no way to know from present evidence. The possibility remains open, not confirmed. The honest boundary is important. No known object within the solar system has been verified as extraterrestrial technology. No lunar structure, asteroid, unusual orbit, spacecraft measurement, or interstellar visitor provides confirmed evidence of an alien probe. The topic remains speculative, but it is useful speculation because it produces scientific questions. Where can long-lived artifacts remain? What signatures would distinguish technology from nature? How can old mission data be compared? Which objects deserve closer observation? How should a candidate be preserved? How can humanity avoid contaminating or damaging it? A good hypothesis guides measurement. It does not replace it. Searching for probes can improve our knowledge of the solar system, even if no artifact exists. Every faint object mapped, every unusual orbit explained, every sample analyzed, every archive preserved. The search makes our own neighborhood less unknown. If another civilization left something here, understanding the natural solar system is necessary to recognize it. You cannot identify the unusual without knowing the ordinary. A probe hunt begins with geology, orbital mechanics, material science, thermal physics, radio astronomy, history of human spaceflight. The alien question depends upon ordinary expertise. A civilization does not need to send a narrow radio beam toward Earth. It could write a message into starlight. A star is visible across enormous distances. Its light travels naturally. No receiver needs to know the correct radio frequency. No antenna needs to point toward a brief transmission at the exact moment it occurs. A civilization could alter the way its star appears, block a small portion of light, reflect light, create a sequence of shadows, or place objects in orbit that produce a pattern whenever they pass between the star and a distant observer. The star becomes the background. The orbiting structure becomes the message. This kind of signal could last for centuries, perhaps longer. An observer would not hear it. They would watch. A star remains steady, then dims slightly, returns to normal, dims again. The intervals form a sequence. 1 day, 2 days, 3, 5. The pattern repeats. At first, astronomers may suspect planets, dust, star spots, clouds of material. These are reasonable explanations. Nature causes stars to change brightness in many ways. But if the timing follows a clear mathematical structure, the possibility of design becomes more difficult to ignore. A planet usually crosses its star, according to one orbital period. The dip returns regularly. Artificial structures could create more complex schedules. Several objects may share one orbit. Their spacing can be chosen deliberately. One produces a shallow dip, another a deeper one. Another blocks a precise fraction of the light. The sequence contains information. The civilization does not transmit energy directly across space. It arranges matter so that the star's existing light carries the pattern. This may be efficient over long timescales. A radio beacon requires power every time it transmits. An orbiting structure may continue producing transits after construction is complete. Once placed correctly, gravity maintains much of the pattern. The message repeats whenever the structures cross the star. A civilization can become silent. The transit sequence continues. This makes an artificial transit a possible archaeological sign. The builders may no longer exist. Their orbital message remains. First contact could have happened whenever humanity first observed such a star. The pattern may already exist inside old brightness measurements. The signal leaves traces at every stage. Oral tradition, written chronicles, photographic plates, digital light curves. Each era receives the message differently. The meaning becomes clearer as instruments improve. This would be a remarkable design, a message capable of waiting inside culture. But altering a star's brightness visibly from another system would require enormous structures or energy. A small transit produces a tiny change. Human eyes would not notice. To create a naked eye pattern, the structures may need to block a significant fraction of the star. This is a vast engineering project, perhaps beyond anything humanity can imagine building. Yet a civilization lasting millions of years may work at scales very different from ours. It may construct swarms of collectors around its star, not primarily as a beacon, for energy. The transit pattern could emerge from ordinary engineering. Humanity observes technology without being intentionally contacted. First contact becomes inference. The structures are not speaking to us. Their arrangement reveals that someone built them. The distinction matters. A beacon is designed to be recognized. A technosignature may be an unintended consequence. Cities on Earth produce light visible from space. Industrial gases enter the atmosphere. Satellites reflect sunlight. These are signs of technology, but not messages. Another civilization may reveal itself similarly. Its star appears surrounded by warm structures. Its planet's atmosphere contains chemicals difficult to maintain naturally. Its night side glows. Its objects move in coordinated ways. Humanity notices. The civilization may not know. First contact begins one-sided. We observe their existence. They remain unaware of ours. Could this have happened already? Perhaps an old astronomical survey recorded a star whose infrared output was unusual. The data were interpreted through limited models. A later telescope examines the source. The pattern has changed. The early measurement is difficult to reproduce. Was the first observation an instrument error, dust, a transient event, or technology that later disappeared? Without repeated evidence, no conclusion can be reached. A civilization may be visible only during one phase. It constructs large orbital structures. Centuries later, those structures are removed, replaced, destroyed naturally, or moved. Earth observes the system during a brief window. If our telescopes are not operating then, the sign is missed. Technosignatures can be temporary. A structure blocks blue light more strongly than red, then reverses. The sequence creates symbols across wavelengths. A telescope equipped with several filters detects information invisible to the eye. Another structure emits narrow spectral lines. One color means 0, another means 1. The star becomes a multi-channel transmitter. The sender may use polarization. Light waves can oscillate in different orientations. Natural processes can polarize starlight, dust, magnetic fields, scattering, but controlled changes could encode data. The total brightness remains almost steady. Only the orientation changes. An observer not measuring polarization sees nothing. The message is present. The instrument is incomplete. This resembles the hidden radio signal discussed earlier. A message can cross Earth continuously while remaining invisible to the wrong detector. A civilization may choose polarization because it carries information without requiring large brightness changes. The beacon appears subtle, perhaps intentionally. The sender wants to communicate with advanced observers, not alter the visible night sky dramatically. A world must develop precision astronomy before recognizing it. The threshold is scientific capability. Another channel could use spectral absorption. Artificial gas surrounds the star or planet. It absorbs light at selected wavelengths. The pattern of missing colors forms a code. Natural atoms and molecules also absorb precise wavelengths. The sender could choose combinations unlikely to occur together. A sequence of spectral lines corresponding to mathematical ratios. The observer first assumes unusual chemistry, then realizes the pattern itself contains information. A planetary atmosphere may serve as the display. A civilization releases stable compounds, not only as pollution, as a beacon. The atmosphere's spectrum becomes a message visible during transits. Every time the planet crosses the star, some starlight passes through its air. The molecules leave their signature. A distant telescope reads the chemistry. The sender chooses compounds representing binary states. One gas abundant, another reduced. The pattern changes across years. A message written into weather and atmosphere. This would be slow, but potentially durable. It may require enormous environmental control. A civilization capable of planetary engineering could use it. More likely, atmospheric technosignatures would be unintended. Industrial chemistry, artificial greenhouse control, large-scale biological modification. The observer detects technology without a message. Still, a deliberate atmospheric beacon is imaginable. If one part is lost, another preserves the message. A beacon in starlight may be especially valuable because stars are already observed. The sender does not need to illuminate an empty region. It modifies a known object. Astronomers naturally return to it. The signal becomes difficult to forget. A radio pulse can vanish. An unusual star remains in the sky. Every night offers another observation. If the pattern repeats, humanity can improve its instruments. A new generation can continue. The star becomes a long-term meeting place. Perhaps the sender chooses a pulsar instead. Pulsars are already precise clocks. A civilization could alter the pulse pattern, not by changing the neutron star itself, which would be extraordinarily difficult. Perhaps by placing material in the beam, blocking selected pulses. One pulse arrives, the next is absent. Then another arrives. The missing pattern encodes information. The pulsar provides natural timing and immense reach. The sender uses a cosmic lighthouse already visible across the galaxy. A listener first sees an irregular pulsar, then realizes the missing pulses follow mathematics. The civilization has placed shutters around a neutron star. The engineering scale would be extraordinary, but the beacon could remain visible for vast periods. A civilization may also use natural masers, bright radio emission produced in certain astronomical environments. It modulates the source, or reflects it. The natural object supplies energy. Technology imposes information. The boundary between nature and machine becomes subtle. The receiver must identify not an artificial source, but artificial control of a natural source. This may be harder. A civilization advanced enough to engineer stars may make technology appear almost geological. It rearranges orbits, controls plasma. Read economy. Its technosignatures resemble new astrophysics. Humanity may observe and assume nature, perhaps correctly. Nature is capable of enormous complexity, but one day, a pattern may display intention. A star's brightness follows prime numbers. A pulsar's missing pulses form a grid. Several stars change together in a synchronized way, despite being separated by light years. Natural processes cannot coordinate them on the observed schedule. A distributed beacon network appears. The galaxy itself has been used as a communication system. This would be impossible to mistake after enough data. The message tells us what we will see. The sky confirms it. Imagine a sequence of transit times. The intervals are 2 years, 3, 5, 7. The next should be 11. Astronomers calculate the date. A decade passes. At the exact time, the star dims. The depth corresponds to the next prime number. The artificial interpretation strengthens. The next interval should be 13 years. Another observatory prepares. The event returns. Humanity realizes the message has been underway for decades. The first contact event was the earliest dip. No one understood then. Recognition came through prediction. The sender may now provide an instruction. After the next transit, observe at one radio frequency. The telescope listens. A signal begins. The starlight beacon has guided us into a direct message. The transition would feel graceful. Nature-like shadows become language. Language becomes conversation. The first stage required only photometry. The second requires radio. The sender has verified that someone is paying attention. It does not waste the richer signal until the receiver proves capable of recognizing the beacon. This could be an efficient strategy. Radio transmission may be narrow and energy-intensive. The sender activates it only after detecting a response. But how does it know we recognize the transit? Earth may transmit a confirmation toward the star, or change one of our own signals. The message provides instructions. Send this pulse sequence after the next transit. The sender receives it years later. Then begins the data transmission. The conversation unfolds through astronomical appointments, every exchange tied to transits and orbital cycles. The star becomes both address and calendar. Could humanity have failed an earlier appointment? Perhaps a transit sequence occurred. A radio listening window followed. No one knew. The sender listened for our reply. Nothing arrived. It concluded that Earth lacked technology. The beacon remains, waiting for another cycle centuries later. First contact almost happened. We were present. The signal was visible. The instructions were not understood. Another chance may come. This is one meaning of missed contact that does not require lost data. The information was observed, but the interpretation failed. A civilization can receive every symbol and still miss the message. Understanding is not automatic. The first shadow reached Earth long before telescopes. No record survives. The second appeared during early written history. Someone described a blinking star. The third reached a photographic plate. The fourth entered a digital survey. The intervals form a pattern. Another event is approaching. Its light has already left the source. It crosses interstellar space now. No telescope can see the shadow before it arrives. The date can be predicted only if the earlier sequence is understood. Perhaps somewhere in an archive, the first clues exist. A researcher may connect them tomorrow, or a century from now. The star will dim, humanity will be watching. Or perhaps the star is ordinary. The old records contain errors. The predicted date passes quietly. The hypothesis fades. Science learns. The search continues. This calm uncertainty is where the topic remains. First contact through the sky may have happened. A transit observed, a flash recorded, a pattern preserved, but no artificial stellar message has been confirmed. The possibility lives within methods humanity can test. Monitor stars over long periods, compare old and new data, search for mathematical timing, observe across wavelengths, make predictions, use independent instruments, treat every unusual event first as astronomy, then ask whether technology explains anything nature cannot. Somewhere, another civilization may have chosen this same approach. It watches the sun, Earth passes in front. The transit repeats every year. Our planet's atmosphere leaves oxygen, water, carbon dioxide, and other chemical signatures. The distant astronomers study the pattern. Then they notice artificial satellites, radio emissions, changing atmospheric chemistry. Perhaps they conclude that technology exists here. They decide to answer using their star. Structures are placed in orbit. The first artificial transit begins. Its light leaves their system. The journey toward Earth takes decades. From their perspective, the message has already been sent. From ours, nothing has happened yet. The star remains steady. The shadow is still traveling. One day a telescope will see the first dip. Researchers may call it a planet. The second dip will differ. The third will form a sequence. At last, the sky itself will begin to speak. Or perhaps the sequence began long ago, and we missed the opening. Either way, the lesson is gentle. Long before radio telescopes, people watched the sky. They watched because the sky helped them live. The rising of certain stars marked seasons. The moon guided calendars. The sun revealed direction and time. Planetary movements became signs of change. Eclipses interrupted the familiar order of day and night. Comets appeared without warning. Meteors crossed the darkness and vanished. The sky was not a distant scientific laboratory. It was part of daily life. A clock, a map, a source of stories. A place where human beings searched for meaning. If first contact happened in the distant past, it would have entered this world of observation without modern instruments. No spectrum, no digital recording, no precise radio frequency, no photograph. Only eyes, memory, language, stone, clay, ink, and stories passed from one generation to another. A real astronomical event may therefore have survived not as data, but as culture. A strange light appears. A star blinks in an unfamiliar way. An object moves across the sky and changes direction. A voice-like sound follows a meteor. A bright body remains visible for several nights. People witness it. They describe it using the concepts available to them. A messenger, a fire in the heavens, a moving star, a divine sign, a celestial animal, a ship in the sky. The description does not tell us what the event physically was. It tells us how the observers understood it. This difference is important. Human beings do not preserve raw experience perfectly. We interpret while remembering. A bright object becomes connected with a political event. An eclipse becomes connected with a battle. A comet becomes connected with the death of a ruler. The sky and human history become woven together. Over time, the original observation may be difficult to separate from the meaning added later. If another civilization attempted contact before modern science, the event could have entered this process. The signal may have been real, the interpretation cultural, the memory altered. By the time written records survive, the original physical details may be almost invisible. There is no confirmed ancient text, artwork, monument, or myth that proves extraterrestrial contact. Ancient accounts of voices or music from the sky may preserve ordinary natural events interpreted through culture or symbolic storytelling. A technological explanation would not become stronger simply because the description sounds unusual. Nature can be dramatic. Human imagination can be richer still. The search must resist the idea that unfamiliar means artificial. The world of ancient observers contained many phenomena modern people rarely experience directly. Dark skies without city light, bright comets visible for weeks, large meteor storms, auroras at unusual latitudes, solar halos, lunar halos, sundogs, mirages, atmospheric pillars, zodiacal light, the Milky Way stretching across the entire sky. A person unfamiliar with these events today might find ancient descriptions extraordinary. To the original observers, some were familiar, others truly rare. Understanding the natural sky is essential before considering anything technological. This is similar to learning ordinary radio interference before searching for an alien transmission. You must know the background. Ancient skies had their own background. A rare natural event could become central to mythology because it was unexpected. A meteor storm may fill the sky with thousands of streaks. A bright comet may develop a long tail. A supernova may become visible during daylight. An eclipse may turn day into darkness. These experiences require no alien technology to feel transformative. The universe already creates events powerful enough to shape memory. Could myths preserve detailed astronomical timing? Sometimes. A story may be connected with a seasonal star, a ritual repeated when a constellation rises, a cycle of years linked with planets. The myth becomes a memory device. Information survives through narrative. This suggests one way a contact signal could be preserved intentionally. The sender might create a pattern that encourages repetition, a visible sequence tied to a celestial cycle. People incorporate it into calendars. Even without understanding the source, they preserve the timing. A future civilization reconstructs the pattern. Imagine a bright pulse occurring whenever two planets align. The event returns every several decades. Ancient observers create a ceremony. The date is remembered. Modern astronomers measure the pulse. The historical timing extends the dataset backward. What appeared as tradition becomes a record of a repeating beacon. Again, no known tradition has been confirmed as evidence of such a signal. The signal arrives during the observation. Ancient contact could use the same logic at a simpler level. A bright planet reaches conjunction. People watch. A pulse appears nearby. The event enters records. First contact may have happened during a moment chosen because someone expected us to look. The difficulty is knowing what ancient people were watching deliberately. Calendars and architecture provide clues. Certain alignments mattered. A sender observing Earth remotely would not know cultural details easily. It might know only celestial geometry. Eclipses are universal. Transits, solstices, planetary conjunctions. These could serve as shared appointments without knowledge of culture. Perhaps an ancient signal arrived during a total solar eclipse. The sky darkened. Stars became visible during day. One unfamiliar light appeared close to the sun. Observers recorded it. Modern interpretation suggests a comet or planet. But suppose the light was an optical pulse from a probe positioned near the sun. The eclipse reduced glare, making detection easier. The sender used the moon as a natural shield. This is clever. It is also difficult to verify historically. The event lasted minutes. No instrument measured the spectrum. Descriptions changed. The possibility remains imagination unless a modern repeat occurs. Could physical artifacts have influenced ancient stories directly? A probe may have landed. People found it, touched it, moved it. Perhaps the object became a sacred item, a strange metal, a polished surface, a material that did not rust. Over centuries, it was lost, melted, buried, or transformed. First contact happened through matter. The evidence disappeared into human history. This scenario is possible in a broad physical sense. Objects can be found and reused. Meteoric iron was valued in some ancient cultures before iron smelting became widespread. Material from the sky had real significance. An extraterrestrial manufactured object could also be interpreted as heavenly, but no known ancient artifact has been verified as alien technology. Claims of impossible materials often weaken under proper dating, contamination analysis, or historical study. A genuine artifact would need extraordinary evidence. Its material should be inconsistent with natural meteorites and human manufacture. Its structure should show engineering. Its age and archaeological context should be secure. Independent laboratories should confirm it. Without these protections, modern contamination or misidentification is far more likely. A sender may deliberately encode information in a way likely to enter song, simple rhythms, memorable repetition, patterns easy to pass orally. 1, 2, 3, 5, 8. The sequence could become a chant. People may preserve it because it sounds structured. The original light or sound event disappears. The rhythm remains. Centuries later, mathematicians recognize the pattern. But mathematics alone does not identify an alien source. Human beings can discover number sequences independently. The contact claim requires a source in the sky, a modern signal repeating the same rhythm. Then the old tradition becomes relevant. This repeated need for present evidence may seem to move the topic away from the past, but it reflects how science works. The past gives clues, the present tests them. Historical claims become stronger when they generate new observations. A story points toward a star. A monument aligns with a date. A record predicts a recurrence. A material contains measurable structure. Without testability, the claim remains narrative. Narratives can still be valuable. They do not need to become science to matter. The search for first contact should not strip stories of meaning simply because they cannot be verified astronomically. Perhaps the most interesting possibility is not that ancient people misunderstood an alien message. It is that another civilization may have understood us. Earth has been visibly alive for an immense time. Oxygen in the atmosphere, seasonal vegetation, clouds, oceans. A distant observer could identify our planet as biologically active long before humans built cities. A civilization may have watched Earth through its own history. It could have seen atmospheric changes, large fires, perhaps artificial nighttime light much later, radioactivity later still. Its relationship with Earth may be ancient on one side and completely unknown on ours. The sender may have transmitted several times. One message reached the planet during prehistory. No receiver. Another during ancient civilization, observed as a strange light. Another during early astronomy, recorded incompletely. Another during radio science, almost confirmed. Contact attempts may track human development without the sender knowing exactly what stage we reached. The intervals are determined by distance. The civilization sees Earth's past. It responds to changes observed centuries earlier. The civilization of Earth becomes one long instrument. The sender may have designed for this, or the pattern may emerge accidentally. Either way, contact unfolds through human continuity. There is another possibility. A real extraterrestrial message may have been mistaken for spiritual experience, rather than an external astronomical event. A person hears a voice, sees a light, receives a vision. Could technology produce such an experience? A directed signal, a physical encounter, perhaps. But personal experiences are difficult to verify historically. Human minds can produce vivid perceptions through dreams, illness, meditation, stress, expectation, and many ordinary processes. Cultural language shapes how experiences are described. Without independent physical evidence, a technological explanation cannot be supported. The respectful response is not to dismiss the personal meaning, nor to convert it into proof of aliens. The experience belongs to the individual and community. Science requires measurements that others can test. This boundary becomes especially important because contact themes can overlap with religious imagery. Beings descending from the sky, radiant figures, messages, journeys among stars. These motifs can arise from symbolism, human psychology, and the natural importance of the heavens. They do not require extraterrestrial visitors. Similar themes appear across cultures because humans everywhere see the sky, experience birth, death, dreams, storms, light, darkness. The universality of the sky creates shared imagery. An alien interpretation should not be added without evidence. If a future message explicitly references one historical event, the situation changes. The sender provides date, location, physical details, perhaps a record of the interaction. Then historians can compare. The event becomes testable after the fact. Until then, ancient personal accounts remain human experiences first. This caution does not make the topic less interesting. It makes the true possibility clearer. A confirmed historical contact would require a bridge from narrative to measurement, an artifact, a repeated signal, astronomical prediction, independent physical data, something capable of resisting multiple explanations. The strongest future discovery may therefore arrive as a modern message containing a historical index. The transmission begins with mathematics, then a map, then a timeline of Earth observations. One point corresponds to a radio pulse, another to an optical flash, another to an object passing near the moon, another to an ancient celestial event. A community gathers beneath a clear sky. A familiar star begins changing. Bright, dim, bright, a pause, then 3 quick flashes. No one knows what caused it. Some are afraid, others curious. One person counts the intervals, another marks them in clay. A storyteller connects the event with a journey. An astronomer returns to the location on later nights. Nothing happens again. The clay tablet survives. The story changes. The star remains. 2,000 years later, a telescope receives a narrow optical pulse from the same direction. The sequence is identical. Bright, dim, bright, a pause, 3 flashes, then numbers. The ancient record is translated again. The first contact event was witnessed. The modern world finally understands. Or perhaps the clay marks describe grain. The story describes a comet. The new pulse comes from an instrument error. The connection disappears under examination. Science accepts that. The beauty of the topic lies partly in not knowing which version the universe contains. Possibility does not need to become certainty immediately. We can imagine the paths while respecting the evidence. The sender may have written into starlight, left an object, triggered a flash, or never contacted Earth at all. The stories may be entirely human, the skies entirely natural. Both possibilities preserve wonder. Human culture is remarkable without alien intervention. The universe is remarkable without artificial signals. If the two histories ever connect, the evidence will need to be strong enough to honor both. Tonight, imagine the oldest human sky. No electric light, no satellites. The stars extend from horizon to horizon. The Milky Way appears like a pale river. Planets move slowly among fixed patterns. A meteor crosses. A comet glows. Perhaps one artificial pulse arrives. It lasts only seconds. Someone sees it. The universe has touched human perception through technology from another world. Yet no shared language exists. No instrument confirms it. The moment becomes memory, then story, then tradition, then uncertainty. The signal continues beyond Earth. Centuries pass. The sender waits. Humanity changes. Telescopes appear. Radio, spacecraft, digital archives. One day, another pulse arrives. This time, the planet is ready. The old story rises from the past. The distance between myth and measurement closes. First contact did not happen once. Modern Earth listens through machines. Satellites watch the atmosphere. Radio telescopes scan broad sections of frequency. Spacecraft measure particles, magnetic fields, and radiation. Radar systems track objects moving above the planet. Optical surveys photograph enormous areas of sky. Computers compare each observation with millions of others. Humanity now collects more information from the universe than any person could examine directly. This creates a new form of blindness. In earlier centuries, a signal could be missed because no instrument was watching. Today, a signal may be recorded by many instruments and still remain unseen by human attention. The data arrive. Software filters them. A decision is made in a fraction of a second. Save, compress, average, ignore, delete. The universe may speak through patterns hidden beneath those decisions. A real message could be passing through Earth right now. Not because anyone has confirmed one, No extraterrestrial transmission has been verified. But because modern observatories continuously remove enormous amounts of interference, background noise, and ordinary activity, this filtering is necessary. Without it, researchers would be overwhelmed. The difficulty is that an unfamiliar technology may resemble exactly the type of noise that software was designed to reject. Imagine a radio telescope observing a nearby star. The receiver collects a broad range of frequencies. Within the data are signals from satellites, aircraft, navigation systems, local electronics, distant transmitters, reflected by the atmosphere. The computer identifies familiar patterns. It removes them. One narrow signal appears briefly. Its frequency shifts quickly. The software assumes it came from a moving human transmitter. The signal is discarded. Perhaps that decision is correct. It usually is. Human technology fills the radio environment. But suppose the source is a transmitter on a planet orbiting the star. Its rapid frequency drift comes from motion. The planet rotates. It orbits. The transmitter may be located on a spacecraft moving near the planet. The signal behaves like a moving source because it is one. The software identifies the correct physical feature. It reaches the wrong origin. A real extraterrestrial signal may resemble human interference because both are produced by technology. This is one of the deepest challenges in the modern search. Technology looks like technology. The machine becomes a guide, not an authority. A model may also reproduce the biases of its training data. If unusual astronomical signals were removed before training, the model learns that the cleaned background is normal. A genuine message resembling removed interference may be rejected again. If the training data contain many satellites, the model may classify anything technological as satellite-like. The intelligence of the tool does not remove assumptions. It can make them less visible. A complex model may reject a signal without giving a clear reason. The event receives a low score. No researcher examines it. A first contact clue disappears inside a mathematical decision no one understands fully. Transparency becomes important. Why did the system reject this event? Which features mattered? Can another model disagree? Can raw data be recovered? A contact search should avoid depending upon one silent judgment. Perhaps several independent artificial intelligences examine the same observations. Each is trained differently. One specializes in interference, one in astrophysical transients, one in information theory, one in orbital motion. Events that confuse all of them receive attention. The models become a panel of imperfect listeners. Disagreement becomes useful. A signal classified confidently by one system and rejected by another may reveal a hidden assumption. Human researchers investigate the conflict. The first contact candidate may appear first as disagreement between machines. One says satellite, another says distant moving source, a third detects mathematical structure. No one model sees the whole. Together, they point towards something unusual. This could already be happening in modern data systems, not contact, but scientific discovery in general. Different methods reveal different aspects. A genuine technosignature would likely require this kind of layered analysis: signal detection, interference rejection, astronomical localization, information structure, independent confirmation. No single algorithm can establish the full conclusion. The modern sky is also watched by instruments whose data are not public. Defense sensors, commercial satellites, private communication networks, navigation systems, weather platforms. Some observe continuously. Some have sensitivities or viewing angles unavailable to scientific facilities. An unusual object may pass above Earth and be detected by several systems. A bright flash may be recorded by satellites. A radio event may interrupt communications across a region. A scientific telescope may see only one part. A radio telescope may cover a broad frequency range, while observing each star only briefly. A satellite may watch Earth continuously, but not retain full resolution data. Coverage on a map does not mean coverage across time, wavelength, sensitivity, and pattern. A message may pass between observations, or remain below thresholds, or occupy a dimension not measured. Humanity's listening window is still small compared with the age and size of the galaxy. This makes missed contact possible without requiring secrecy or incompetence. The search problem is simply vast. The modern world adds another source of confusion: deliberate human transmissions that imitate extraterrestrial signals, tests, pranks, art projects, uncoordinated beacons, spacecraft, signals reflected from celestial objects. A candidate may appear to originate beyond Earth while actually coming from Earth and bouncing from the Moon or an asteroid. The reflection changes frequency and timing. The path can be complex. A signal may travel from one continent, reflect from a satellite, enter a telescope, and appear linked to a target star for a brief moment. Investigators must reconstruct the entire radio environment. The more technology humanity places in space, the more complicated this becomes. A genuine extraterrestrial message may be hidden inside a growing forest of human signals. Future searches may need protected radio quiet zones in space, observatories far from Earth, careful catalogs of transmitters, standard ways for spacecraft to identify themselves. Human civilization must make its own technological activity understandable before it can confidently identify another. This is almost like cleaning a mirror. The distant signal may already be there. Our reflection covers it. Could another civilization face the same problem? Certainly. Its own satellites and communication systems may overwhelm Earth's weak leakage. Our signals arrive. Their filters reject them as local technology. A transmitter on Earth accidentally resembles one of their devices. The alien observatory discards it. Both civilizations become hidden by their own noise. Technological development increases detectability from afar, but also creates local interference. A world becomes louder outwardly and more deaf inwardly. This paradox may be common. The solution is intentional listening from quiet locations. This is a promising use of computation, not declaring contact. Finding relationships worth testing. The danger is finding accidental relationships in enormous datasets. With enough sources, coincidences are inevitable. A radio pulse will align near some unusual star by chance. An interstellar object's path will pass close to many sky positions. A mathematical pattern can be fitted after the fact. Statistical discipline remains essential. How often would such alignments occur randomly? Was the relationship predicted before new data? Does another independent event follow? The contact hypothesis should become more specific over time. It should risk being wrong. A model that explains every possible outcome explains nothing. If the signal is artificial, it should predict where to listen, when, at what frequency, what orbital motion to expect. Each prediction gives the universe an opportunity to reject the idea. A genuine message can survive this. Coincidence eventually fails. This process may take years. The first contact candidate may live quietly within science before the public accepts it. A small team monitors one star. Signals repeat. Several papers appear. Natural models weaken. A spacecraft transmission remains possible. Then an exoplanet is confirmed. The signal's drift matches its rotation. A mathematical sequence appears. Independent observatories confirm. Confidence grows gradually. No single dramatic announcement. At some point, the probability of an ordinary source becomes too small. The conclusion changes. The discovery may feel sudden publicly. Scientifically, it was built step by step. Could humanity already be inside such a process without knowing? A candidate may exist within current research, not one publicly confirmed. Perhaps one event receives quiet follow-up. Perhaps several unusual signals are being checked. Most will become interference. This is normal. The search constantly produces candidates. The important fact is not whether one rumor is true. It is that the system of verification exists. A real signal would need to pass through it. The title asks whether first contact already happened, and we missed it. In the digital age, missing may not mean failing to record. It may mean failing to connect, failing to preserve, failing to question a label, failing to observe long enough, failing to share across institutions. The alien message begins with Earth's own voice returning after decades. First contact happened when they heard us. We missed the reply until we remembered what we once sent. This would connect digital archaeology with astronomy, old communication standards, broadcast schedules, radar patterns, spacecraft commands. A response could contain any of them. Preserving technological history may therefore help identify future contact. The sender may have intercepted leakage rather than a deliberate message. It returns fragments of ordinary communication, a weather satellite transmission, a navigation signal, a television carrier. The content may be too degraded to reconstruct, but the modulation is unmistakably human. The source star is distant. No human spacecraft is there. Another civilization must have received and repeated it. The proof lies in our own technological fingerprint. Could such a response already be hidden in data? A signal resembling an obsolete Earth transmission may have been dismissed as interference. Researchers assume it came from old hardware nearby. Perhaps it did, but if the direction and timing point toward a star, the resemblance becomes important. Searching for echoes of Earth's past may be one strategy. Not only generic artificial signals, patterns unique to transmissions that left our planet long ago. The expected target systems depend upon distance. A signal sent 40 years ago reaches a star 20 light-years away, and a reply could return around now. The geometry creates windows. Researchers can calculate when answers become possible. This does not mean any answer exists, but it narrows the search. A response cannot arrive before light has had time to travel both ways. Historical transmissions and target distances create schedules. The first contact reply may be mistaken for random noise if no one is listening during the correct period. Modern automation can maintain watch across generations better than individual projects. A system preserves the schedule, updates target information, observes during expected windows. If no signal arrives, it continues elsewhere. If one appears, the original outgoing message is available for comparison. The conversation gains continuity. Perhaps another civilization uses the same method. Its machines maintain long-term listening. Its biological generations change. The contact program remains. First contact may already be recorded, not lost, waiting. Somewhere inside a data center, magnetic tape library, cloud archive, private satellite record, or obsolete file format. The signal may be incomplete or complete. Its importance may depend upon an observation not yet made, a future pulse, a newly discovered planet, a probe arriving. The archive and the future may meet. Imagine a researcher examining rejected candidates from several decades. One signal appears repeatedly, never strong enough for attention. Each detection came from a different telescope, different hardware, different countries. The frequency changed between events. This once made the candidates look unrelated. The researcher corrects for the motion of a nearby star. The signals align, then corrects for a planet orbiting it. The timing becomes regular. The transmitter was always on one frequency in its own moving frame. Earth's motion and the planet's motion spread it across the archive. Humanity had been listening for years. The message was divided by our changing viewpoint. Once corrected, the data combine. A clear sequence emerges. The first block is repetition. The second contains mathematical structure. The third remains unreadable. The signal is real. The earliest recording predates the researcher's birth. First contact occurred then. Recognition happens now. The announcement begins with a date long past. On this night, Earth first received a confirmed signal from another technological civilization. At the time, it was classified as interference. Later observations show that it was the opening of a continuous transmission. The world learns that it has been in contact unknowingly for decades. This would change the emotional shape of the discovery. There was no sudden arrival today. The universe did not become inhabited overnight. Our knowledge changed. The signal had been present. The civilization had been present. The relationship began quietly inside machinery. Perhaps this is how many great discoveries feel. The reality existed before recognition. Planets orbited other stars before we detected them. Galaxies existed before humanity understood them. Microorganisms existed before microscopes. The unknown is not created by discovery. Discovery changes the map within the mind. First contact may follow the same pattern. Someone else may already be part of reality. Their signal may already be part of our data. The first credible signal would not become first contact in a single instant. It would become first contact through a sequence of increasingly difficult questions. Is the signal real? Is it astronomical? Is it artificial? Did another civilization intend us to receive it? Does it contain information? Can that information be understood? And finally, should humanity answer? The first detection may take only seconds. The process that follows could take years, perhaps generations. A radio telescope records a narrow signal from one nearby star. Another observatory confirms it. The signal's frequency changes in a way consistent with a planet's rotation. It disappears when the planet passes behind its star, then returns. The transmission contains a repeating sequence, not one simple tone, a structured pattern. The evidence begins to gather. Yet the first responsibility is not interpretation. It is verification. The receiving civilization must ensure that the signal truly comes from where it appears to come from. Every ordinary possibility is examined again. Satellites, aircraft, ground transmitters, spacecraft, instrument electronics, software errors, reflections from the moon, radar bouncing from asteroids, unexpected harmonics produced by nearby equipment. Even if the signal appears at several observatories, researchers must ask whether those facilities share a hidden source. The same satellite network, the same clock system, the same software, the same interference database. Apparent independence can be deceptive. A strong verification effort uses instruments that differ, different continents, different antenna designs, different processing systems, perhaps a radio telescope in space, perhaps a receiver on the far side of the moon. If all observe the same signal with the timing expected from one point beyond the solar system, the terrestrial explanation becomes much weaker. The signal must also behave like something attached to an astronomical source. Earth moves around the sun. The source star moves through the galaxy. A planet may rotate and orbit. These motions shift the received frequency. The change is small, but predictable. A genuine transmitter on that world should carry the motion of its environment. The signal may rise and fall in frequency as the planet turns. A longer curve appears as the planet moves around its star. The pattern becomes a fingerprint of location. The message begins constructing a system of units that does not depend upon meters, seconds, or local history. This may feel like an alien version of scientific notation. Once the shared units exist, the sender can describe its world, the diameter of its planet, its star's mass, the length of its year, the pressure of its atmosphere, the temperature of its oceans. The message turns from abstract mathematics toward place. A map may follow, not a picture in the human sense. A set of distances and directions. Nearby pulsars could serve as markers because their periods are distinctive. Stars with known spectra. The source's position relative to them. Humanity compares the map with astronomy. The location matches. The signal becomes self-locating. Then perhaps Earth appears. The map shows the sun, 8 major planets, one highlighted. The sender identifies the world it believes produced our signal. Perhaps it gets details wrong. Earth's moon is shown with an inaccurate orbit because the sender observed us from far away. One planet is missing, or a dwarf planet is counted differently. These imperfections would make the message feel more real. The sender works with limited observations. It does not possess perfect knowledge. The message may ask for correction. Is this your system? Did this signal come from the third planet? Contact begins with uncertainty on both sides. The next section may introduce chemistry. Atoms represented through proton numbers, electrons, bonds, molecules, water, carbon dioxide, oxygen, ammonia, methane. The sender may describe its atmosphere and biology, but biological communication is difficult. Another world's life may use unfamiliar chemistry, perhaps carbon and water, perhaps not. Even if chemistry overlaps, biological organization may differ greatly. The message needs to define cells, replication, metabolism, evolution, bodies, individuals. Some concepts humans assume to be obvious may not apply. The sender may not consist of separate organisms. It may be a network, a colony, a distributed intelligence spread through machines and biological systems. When the message says we, the meaning could be difficult. One civilization, one species, one mind, many minds sharing memory. An automated archive speaking for extinct creators. Translation becomes philosophical before ordinary conversation begins. The receiver may initially interpret symbols as individuals. This honesty may be more meaningful than an artificial claim of unity. A reply could contain several human greetings, different languages, music, mathematics, images, scientific data, but too much complexity may make the message difficult to decode. The earliest response should perhaps mirror the structure of the received signal. Use the sender's mathematical framework. Return one known sequence. Add a modification. Demonstrate comprehension. Conversation can begin small. They send prime numbers. We return primes followed by another recognizable sequence. They send a map. We return a corrected map. They define one unit. We use it. Shared meaning grows through interaction. This is how two strangers without common language may communicate. Point, repeat, confirm, expand. Interstellar distance makes the process slow. A nearby civilization 10 light-years away requires 20 years for one question and answer. The first reply sent today reaches them in 10 years. Their response returns 10 years later. A misunderstanding can persist for decades. Every message must anticipate delay. The sender cannot clarify immediately. It may include many possible explanations, examples, questions with multiple choices, instructions for indicating misunderstanding. Communication becomes carefully engineered. Perhaps the received message already contains a conversational tree. If you interpret this symbol as time, transmit sequence A. If as distance, transmit sequence B. The sender predicts likely ambiguities. Humanity's reply selects one path. Years later, the next message continues from there. The conversation resembles two civilizations solving a shared puzzle across generations. No individual experiences more than a few exchanges. Children inherit questions asked before they were born. They help prepare answers whose replies arrive after they are gone. First contact becomes part of civilization's long-term memory. Institutions must preserve every message. Original data, translations, alternative interpretations, decisions. The context cannot be lost. A future generation needs to know why one reply was sent, which assumptions it contained, what uncertainties remained. Without this record, the conversation can drift. A symbol interpreted one way in the first century may be reinterpreted later. The distant civilization's response may then appear confusing because it follows our earlier mistake. Contact requires communication with our own future as much as with them. The archive becomes a third participant. Earth, the distant world. The reply becomes a portrait of plurality. But the earliest exchange may remain simple enough to decode. Complexity can wait. The first task is mutual recognition. You are real. We are real. We understand that you understand. This loop completes contact in a stronger sense than one-way detection. A message arrives. Humanity responds. Years later, the sender refers specifically to our reply. The civilization beyond Earth has not merely broadcast. It has heard us. The conversation is confirmed. Perhaps this has already happened without our awareness. An Earth signal reached another world. They replied. Their message arrived decades ago. Humanity recorded it, but did not recognize the connection. We never answered again. From their perspective, the conversation began and then stopped. They may have sent follow-up messages. One is still traveling. The recovered archive tells us the first reply was received long ago. The current message may say, "We answered your transmission. We received no confirmation. We are repeating." This would carry a quiet sadness, not emotional sadness necessarily. A communication attempt left incomplete. The sender waited through its own generations. Perhaps it now assumes Earth's technology disappeared. A civilization can become detectable and then fall silent. The sender may wonder whether we survived. The repeated message could be a final attempt. Humanity's reply would not merely say we heard. It would say, we are still here. The delay becomes part of the meaning. They heard an earlier Earth, perhaps before the internet, before current nations, before many living people were born. Their reply addresses a world that has changed. The signal may repeat a broadcast voice from decades ago, a person long dead, music from another era, a scientific message transmitted by researchers who never expected an answer. The past returns from the stars. Humanity hears its own history inside alien data. This would create an extraordinary emotional connection across time. The original senders become part of first contact posthumously. Their work crossed space, was noticed, inspired a response. They never lived to know. Future historians reconstruct their project. Old equipment, notes, debates, the moment of transmission. The reply completes their story. First contact becomes a collaboration between the dead and the living. The sender may face the same situation. Another world's reply may arrive through the same system. A conversation can occur between historical civilizations through preserved records. The galaxy becomes less like a live meeting place and more like a library passing between stars. Humanity adds its own volume. This may be the realistic form of galactic community, not simultaneous voices everywhere. Archives, beacons, probes, delayed responses, civilizations connected through patience and preservation. The first decoded message might therefore contain many voices, not one sender, fragments from worlds encountered earlier. Each introduces itself. Some messages are millions of years old. Some contain biology unlike anything known. Some report no longer receiving replies from their origin. The beacon preserves them anyway. Humanity's first contact becomes many contacts at once. This would be overwhelming. Researchers may need decades merely to catalogue the archive. The emotional impact could be gentle and enormous. The universe was not silent, it was slow. Messages accumulated. Civilizations listened across different eras. No one voice reached us clearly until now. Or perhaps the message contains only one simple greeting. No vast archive, no technology. A beacon saying, "We existed. This is where, this is when." The sender may have faced extinction, a changing star, planetary disaster, long decline. It built a transmitter to preserve evidence beyond its own future. The message is not an invitation to conversation. It is remembrance. First contact becomes encounter with a civilization that knew no reply would reach it in time. The message may describe its world, life, history, questions, then end. No active receiver remains. Humanity can answer, but no one may hear. Still, the act of receiving fulfills the sender's purpose. Someone knows. The civilization is no longer entirely lost. This would give first contact an archaeological character, even though the signal arrived through radio. A message can be a monument made of light, repeated until the transmitter fails. The last pulse may already have left. Earth receives the archive one final time. Earlier copies may have crossed the solar system before radio telescopes existed. The message has been passing us for centuries. Only the final repetition is detected. First contact almost missed completely. The sender's last chance becomes our first. The receiver may feel urgency to preserve every bit, not fear, care. Contact is a timeline, not a point. This may be the final answer to the question behind the entire script. First contact may already have happened in one stage while remaining incomplete in another. A signal may have reached Earth. A probe may have observed us. Another civilization may have received our emissions. A response may already be traveling. None of these is confirmed. But the concept of contact itself is layered enough that beginning can precede awareness. Imagine that humanity decodes a timestamp within the message. It marks the sender's first detection of Earth. Their calendar is translated into physical units. Researchers calculate the date. It corresponds to a powerful radar transmission from our planet. The signal left Earth 76 years ago, reached the source 38 years later. The distant civilization analyzed it, sent a reply after 2 years. That reply arrived today. For humanity, first contact seems sudden. For them, it has been a 40-year project. Their scientists may have spent entire careers studying one weak Earth pulse. Some died before the answer was transmitted. Others inherited the work. The message includes their names or equivalents. A chain of observers. The first one noticed, another verified, another decoded, another argued for response. The story mirrors ours before we have even finished living it. The distant civilization may ask whether the original Earth transmitters still exist. The reply may refer to a facility dismantled decades ago. A political system changed. A language evolved. Humanity answers. The individuals who sent the signal did not know you would hear. Many are gone. We received your response. The conversation begins between descendants on both sides. This could create a sense of shared mortality. Civilizations are long. Individuals are brief. Messages cross the gap through institutions and memory. The most important technology may not be the transmitter. It may be continuity. The ability to care about an answer that arrives after the original questioner is gone. The sender's message demonstrates that care. Humanity's reply must do the same. A contact program cannot depend upon short-term attention. Funding cycles, political changes, public excitement. The conversation may go quiet for 20 years while the response travels. The receiving civilization must maintain commitment during silence. First contact would change the meaning of the past. Not because every mystery would suddenly become alien, not because every strange light, unexplained signal, ancient story, or unusual object would receive one simple answer. Most would remain what careful investigation already suggests. Natural events, human technology, instrument errors, incomplete observations, stories shaped by culture and memory. But one confirmed message could change the context surrounding them. humanity would know that technological life exists beyond Earth. The possibility would no longer be theoretical. Researchers would return to old archives with a new question, not, can we turn this mystery into evidence of aliens? But does this earlier event connect physically with the confirmed source? The distinction matters. A known sender creates testable relationships: direction, timing, frequency, orbital motion, repeated symbols, previous transmission dates. The new message may unlock one old observation, or several. A radio pulse once classified as unresolved may match the sender's beacon. A faint optical flash may correspond to an earlier attempt. An unusual object may have followed the trajectory described in the message. A forgotten data file may contain the opening section of the transmission. First contact may become older each time another connection is verified. The recognized event happened today. The first arrival happened decades earlier. The first transmission left its world earlier still. The sender may have observed Earth centuries before that. Contact becomes a history extending backward through light. This would alter the way people imagine the universe. The sky would remain physically the same. Stars would continue rising. Planets would follow their orbits. The Milky Way would remain a pale river across dark locations. Yet one point of light would carry a different meaning. Not only a star, a place connected with intention, a world where something noticed us. A transmitter may be too faint to see. The planet may remain unresolved. Still, knowledge would give the point depth. Someone built instruments there. Someone studied the sky. Someone preserved information. Someone decided that another intelligence might exist near the sun. The distance would no longer feel empty. It would feel occupied by travel time. Messages crossing, questions waiting, answers approaching. Perhaps the most profound change would be simple. Messages encoded in ways not yet understood. Civilizations listening during different centuries. Contact may be rare, not because intelligence is absent, because synchronization is difficult. A sender active for 1,000 years may transmit during the receiver's pre-technological age. The receiver becomes capable after the sender falls silent. A probe or archive can bridge this mismatch. The recovered message may reveal that long-lived communication systems are essential. Civilizations do not need to overlap biologically. Their records can. One world leaves a beacon. Another finds it later. The second replies. A third civilization may eventually receive both. Knowledge accumulates even when societies do not coexist. The galaxy becomes a conversation among archives. Humanity may decide to contribute. Even before understanding the entire alien message, we may build durable beacons of our own, not loud announcements sent carelessly. Carefully designed archives, placed where future receivers can find them, clear about uncertainty, containing knowledge of Earth and the contact we received. The recovered signal becomes part of our outgoing record. We say, this message reached us. We understood part of it. We answered. Perhaps you are receiving after both civilizations changed. Here is the history. First contact then expands beyond two worlds. Earth becomes a carrier of another civilization's memory. The sender's message continues through us. The reply may travel toward its origin. Copies may travel elsewhere. Contact creates a chain. This possibility raises ethical questions. Do we have the right to retransmit another civilization's archive? The sender may specify permission, share freely, or address only the receiver. Its concepts of privacy may differ. Humanity must learn not only how to decode information, how to respect it. A message may contain personal records, biological data, cultural material not intended for every world. The sender may divide public and restricted sections, but restriction across alien technology is difficult to interpret. An unopened block may be encrypted, or corrupted, or dangerous, or private. Should we attempt to break it? Curiosity alone may not justify access. First contact could introduce a new form of ethical restraint. The unknown archive belongs to someone, even if its creators are distant or gone. Identity across time becomes central. What makes a civilization the same civilization after centuries? Language changes, governments change. Species may alter itself biologically. Machines may become members. The sender may consider continuity to reside in memory, or location, or institutions, or values. Humanity has its own debates. Contact makes them practical. A reply addressed to the original sender may reach descendants who do not consider themselves the same society. Will they still answer? Perhaps the message includes an invitation to whoever receives it, not only the original civilization. The contact archive becomes transferable. A world can inherit an old conversation. Future humans may answer on our behalf. Another species evolving on Earth long after us could find the records. The message might reach them. Contact crosses not only generations, potentially species. This long perspective can feel almost impossible to hold, yet the signal itself embodies it. Light travels without concern for lifetimes. A civilization choosing to transmit accepts that the receiver belongs to an unknown future. The act is an offering beyond control. Humanity may learn to think similarly. What knowledge would we send if we could not know who receives it? A powerful state? A young society? A machine? A biological collective? A civilization emerging after catastrophe? The safest message may begin with basic truths and an invitation. Not demands, not assumptions. A clear origin, a statement of uncertainty, a method for reply. The alien signal may already follow this design. Its creators solved the same problem. The form of their answer teaches us how to answer others. Perhaps first contact does not make humanity feel small. It makes our responsibilities feel larger. Earth becomes one known inhabited world among at least two. Our biosphere becomes part of a wider history. The choices made here may eventually be known elsewhere, not watched constantly, not judged by a perfect observer, simply connected. A distant civilization may receive our message centuries later. What we preserve and send becomes part of how Earth is remembered. This could encourage care for the planet, not because aliens will rescue us, because Earth is the source of everything we can contribute: life, language, art, science, history. The message outward depends upon a living world inward. Perhaps the beacon was built during one brief period and maintained by simple machines afterward. The contact archive may contain gaps, lost eras, conflicting records. Its history is not a smooth progression. This would again feel familiar. Civilizations are not single lines. They remember unevenly. The sender may have missed parts of its own past. It asks us questions about archaeology, because it too studies forgotten beginnings. Perhaps it discovered an artifact from an older civilization in its own system. First contact for them happened through archaeology. That artifact inspired the beacon reaching us. The message is already part of a chain. An ancient civilization left a probe. The sender found it, learned that intelligence existed elsewhere, then built new transmitters. Earth receives one. Our first contact is indirectly connected with a civilization older than the sender. The galaxy's history becomes layered. No one world begins the conversation. Each inherits traces. Humanity may eventually send onward. First contact becomes tradition. This possibility gives another meaning to missed contact. The beginning may be older than either civilization involved. A message copied from a probe. Symbols passed through several worlds. Meanings changed. Errors accumulated. Each civilization added context. By the time Earth receives it, the archive contains a history of communication itself. One section may be undecipherable because its original language belongs to a civilization gone for millions of years. The current sender preserved it without full understanding. It asks us to help. Contact becomes collaborative archaeology across worlds. Perhaps humanity recognizes a pattern the sender missed because our mathematics develop differently. We decode one layer. The sender decodes another. Together, two civilizations recover a third. This would show that difference can be strength. No single intelligence sees every pattern. Different histories create different tools. Contact expands understanding through contrast. The sender may value us not because we are advanced by its standards, because we are different. A new perspective, a new way of classifying, a new archive of one planet's life. Humanity may feel the same. The value of alien knowledge is not only superior technology, it is another viewpoint on reality. Even where our science agrees, the path toward it may differ. The search becomes meaningful, even before discovery. It teaches how to handle uncertainty, how to preserve evidence, how to cooperate, how to distinguish explanation from desire, how to think across generations, how to address an unknown intelligence with care. Perhaps first contact already happened and we missed it. Perhaps it is happening slowly now. Perhaps it remains far in the future. Perhaps no message will ever arrive. Every possibility returns us to the same night sky. The difference lies in how we observe. Imagine Earth from far away. a small world crossing the light of the sun, its atmosphere showing water, oxygen, clouds, and seasons, artificial signals leaving its surface, radar beams, spacecraft communications, narrow transmissions. For more than a century, traces of technology have moved outward. Some spread weakly, some travel in narrow directions. They pass nearby stars. Perhaps no one is there. Perhaps instruments receive them. Perhaps one distant researcher notices a strange pattern, a signal from a yellow star. It appears once, no repeat. The candidate is archived. Years later, another Earth transmission reaches the system. The relationship becomes clear. Their first contact already happened. They missed it. They begin constructing a reply. The message leaves their world. It travels toward the sun. Between the stars, nothing marks it visibly. No glowing line, only an electromagnetic pattern moving through space. Years pass. On Earth, telescopes continue observing. People ask whether anyone knows we are here. The answer may already be traveling, or not. We cannot know yet. But one night, a receiver may detect a pattern. At first, a candidate, then another observation. A source following a planet, numbers, a map, a fragment of Earth's own signal. The long uncertainty begins to narrow. Someone heard us, someone answered, and perhaps the answer reached us once before. Researchers open old archives. There it is, faint, incomplete, waiting. The recognized message changes the date of contact. The universe had already responded. Humanity had already received. Understanding arrived late. This would not make our earlier ignorance foolish. We listened with the instruments available. We classified according to evidence. We needed repetition, context, better methods. The discovery becomes possible because science allowed uncertainty to remain. The old event was not declared alien. It was not erased from memory. It waited between those extremes, unknown, preserved. This may be the ideal state for every unresolved candidate. Not belief, not dismissal. A careful question. The future may answer, and if no answer comes, uncertainty remains honestly. The night does not become less beautiful because it has not explained itself. Stars shine without needing to contain messages. Natural worlds are enough to inspire wonder. Pulsars, comets, dust, interstellar objects, galaxies. The universe has already given us extraordinary phenomena. Contact would add another layer. It would not create wonder from nothing. Perhaps this is why we can approach the question calmly. We are not waiting for the universe to become meaningful. Meaning already exists in observation, life, and curiosity. Another civilization would expand the story, not begin it. Humanity is already part of the cosmos. The atoms in our bodies formed through ancient stars. Earth moves within the galaxy. Our radio signals join the wider electromagnetic universe. Contact would reveal another participant, but our connection with the universe does not depend upon receiving a reply. The act of listening is itself part of cosmic history. A living world became capable of asking. Built instruments, preserved signals, imagined unknown minds, sent messages outward. Whether anyone answers or not, this happened. Earth became a listening planet. That may be one of our most remarkable achievements. The sender, if one exists, may recognize this. Its message may not celebrate our power. It may celebrate our attention. You looked beyond your world. You noticed. You answered. The contact process begins with this simple capacity, to recognize that reality may contain more than ourselves. Even without proof, the search encourages that perspective. Our assumptions are local. Our history is one history. Our biology is one experiment. The universe may contain others, or it may not. We remain willing to learn. This openness is not belief in aliens. It is acceptance that evidence can change understanding. A strong signal would change it. A natural explanation changes it too. Every resolved candidate teaches us what the universe can produce. As this journey comes to an end, allow the question to remain open. What if first contact already happened? Perhaps one signal reached us and passed unnoticed. Perhaps another civilization received Earth's transmissions and already considers us discovered. Perhaps a patient machine waits within the solar system. Perhaps an old archive contains the first fragment of a message whose next part has not yet arrived. Or perhaps first contact still belongs entirely to the future. A night when one pattern survives every test. A world beyond Earth becomes known, and humanity answers. There is no need to choose one possibility tonight. Let the ideas drift gently. Radio waves crossing darkness, old observatories preserving the sky, distant planets turning beneath unfamiliar stars, messages traveling farther than their creators can follow, civilizations waiting through generations, a question leaving one world, an answer approaching another, and somewhere between them, the long silence of space carrying information quietly. Slow your breathing, allow your shoulders to rest. The universe will continue moving, whether we remain awake or fall asleep. Stars will rise, planets will orbit, telescopes will listen, archives will wait. Any signal crossing the night will continue its journey. There is nothing you need to solve now. The question can remain among the stars. Perhaps tomorrow brings only familiar radio noise. Perhaps another natural mystery. Perhaps one small observation that becomes meaningful much later. Science will continue patiently, and so will the sky. This has been Nightfall Science. Tonight we explored the possibility that first contact may not begin with a dramatic arrival, but with something already received and not yet understood. A forgotten signal, a quiet probe, a pattern inside starlight, an ancient observation, a message filtered as noise. We followed the path from detection to verification, from archives to decoding, and from one missed beginning toward a possible conversation across generations. No confirmed evidence shows that extraterrestrial contact has already occurred, but the possibility reminds us to listen carefully, preserve what we observe, and remain honest about what we do not yet know. As you rest, allow the distances to feel calm rather than empty. The stars do not need to answer tonight. Their light is already reaching us, and if another message is traveling somewhere between those distant points, it will continue quietly while Earth turns beneath the night. Another journey through space and science will be waiting whenever you are ready to return. Until then, let your thoughts soften, let the questions drift farther away. Sleep well, and good night.